Well, welcome everyone to Redis Monthly Live. This is our very first broadcast, so we appreciate you tuning in and watching the show. My name is Guy Roast, and I'm going to be your host tonight. Redis Monthly Live is a regular stream that we're going to be doing here at Redis Labs, where we host live speakers from around the world, so the live part. We're going to do this every month on the third Monday at 7:30 p.m. Eastern Time, 4:30 p.m. Pacific Time, every month. So that's the monthly part. And then, of course, it's all about Redis. And so that's the Redis part. So Redis Monthly Live. Easy. This particular month, we have, we have Otvio Santana. He's going to be talking to us about Eclipse JNoSQL. But before I introduce him, we have a little segment that is the Redis Command of the Month. And that's going to be presented by Justin Castilla. And after we're done with all the talky talk bits, we're going to go and hang out in Discord. And I have a link here at discord.gg/Redis. We'll go hang there and actually have some direct interaction with the audience. So we'll be on Discord. You can join us on Discord, and we can go into the voice channels and just chit chat about whatever strikes your fantasy. Hopefully Redis, hopefully the things we talked about tonight, hopefully interesting stuff. So I think we're going to get started with the command of the month. Justin, are you ready? I think I have you muted.
Yep, I am good to go.
Okay. So I'm going to make this all yours. Here you go. Otávio, I'm going to go ahead and hide you for now. And the floor is yours.
Thank you. Just a little background on this command. Guy and I were hanging out, just trying to figure out what to go for. And both of us are sword and sorcery fans. So this name of this command stood out. I give you the saga of strago. Strago, which is short for string algorithm. We'll play with this in just a little bit. So this is not strago, of course, it's Conan, but moving on. So what is strago? It's not a proud warrior. It's a command to implement complex algorithms on strings, not normally implemented in standard libraries. So right now, strago only has one algorithm to use. It's the largest common subsequence. So if anybody wants to implement their own string algorithm and throw up a PR, that'd be much appreciated. This is available with 6.0 releases and later, so it's somewhat new. And for LCS, the largest common subsequence, it's a time complexity of O of string length 1 and string length 2. So it's going to give a little spoiler away. It's going to be comparing two strings. So this does cost a bit. So you might want to spring up your own separate Redis instance if you're going to be running this in production. So what is LCS? Find the longest common subsequence, not substring, between strings. That was a little surprising to me. I thought it was going to be a substring. But as an example, we have excellence and extraneous. And so it's going to go through the word and pick the letters that are similar, and it's going to return a string of letters that both strings have in common. So it's not going to be just EX and just EX here because they are both within those two words. It's going to collect all the letters. So Selly and Tra are not going to be in our final return. It's going to be Xney because both of these have that sequence of letters, which is kind of interesting. So what is it good for? Data comparison. You can see the similarity between two strings, which is interesting in a lot of different ways. We can do diff checking. That's what diff checking utilities are based off of, I believe. Tracking Git changes. And one of the bigger ones is for bioinformatics for DNA sequences. So let's look at some actual code examples. Up here is an example of just the implementation. So strago is the name of the command, followed by the name of the algorithm you want to use. So in this case, we can only use LCS. And then there's a couple different arguments that we can use with LCS. So I'll go over those as well. So if I call strago or string algo LCS, I'll use strings to tell the command that I'm using strings as arguments. I'm going to compare excellence and extraneous. And I get the string Xney. So EX and E are the similarities between those two words. This is a huge argument in our actual Redis University YouTube channel internally, indices or indexes. I'm team indices personally, but we can see the similarity between the two words is INDES, so indies. And then lastly, Horatio Hornblower. Well, both of those words contain the subsequence HORO. So that's what we get in return. So let's look at some options color-coded for your ease. Let's compare excellence and extraneous, but this time we just want the len, or the length. So we'll get 4 as return, which is EX and then ES, or NE. So we can also use IDX, which gives us the index and locations of the matches. So you'll get something like this, which should look familiar within a Redis command. And it's going to give us the indexes or indices of the matches, starting at the end and then going up to the front, because that's an interesting little quirk of this algorithm. Is it goes all the way to the end of the string and works its way back up to the front. And as a little lanyap, it also gives you the length, total length of the matches. Next, we're going to have index with a minimum match length. So if I only wanted to see matches within my string algo of LCS on these two strings, and I want to see if only 3 or more length, then it'll give me the actual start and end positions of that match. So let me go back here. You'll notice that we saw 5 and 6. Well, if I only want 3 or more, it's only going to give me from 0 to 2, the position of 0 to 2. So IND, basically. So, and I can also have another option called with match len, which will just basically spit out the length of, the length of that specific match. Now, notice it's min match length 3. If I have a length of 4 or 5 matches, it'll also spit those out, meaning I just want to see larger matches rather than all these little tiny 1-off or 2 sequence matches. So it's not just with strings. We can also run string algo LCS with keys. So here you'll see me setting 2 keys. Example 1 is fibrous substrate, and example 2 is Fibonacci sequence. And if I compare both of those with the keys option and then naming both of the keys, I'll get FiboSu. And also notice that the space is also matched in there. So if you don't want spaces, you'll want to actually strip out empty spaces within your strings. Otherwise, you're going to actually get spaces in your match. So something to remember. So let's get a little bit bigger, though. So this, you might, if you squint really hard, you might see that these are actually DNA sequence snippets. So these are each 1,000 characters long, consisting of A's and C's and T's and G's. And this is just a little text file example. I created a text file containing instructions to create 2 strings, DNA:1 and DNA:2. Here I am piping that actual text file into my command line and actually setting those, because I don't want to copy and paste that. And then I'll just call string algo LCS keys, because again, I'm just giving them keys, not actual strings, DNA:1, DNA:2. And this is actually going to give me the subsequence string that results from comparing those 2 strings. Now, this is visually compelling, but not very useful or interesting until we actually get some facts and figures. So we can actually call the options that we had for our strings on these keys. So the length of the subsequence that matched between those 2 strings is 640. So 640 matches out of 1,000 character string. That's actually information that's slightly remarkable. And if I call index on the 2 DNA keys with a min-match length of 7, so I want to see the amount of values, the amount of matches that have 7 in length within that string. And I also want to see the min-match length. So how long was that actually found? This is what I get. So in my first DNA:1, there's a match between position 335 and 341, which is 7 long. In my second key, DNA:2, there was a match between position 358 and 364. And this again tells me if I like what the match length was. If I dropped down this min-match length to maybe like 6 or 5, I would receive more matches to look at, and it would tell me the integer size of each match from 6 to 5 to 7 or whatever I want to put in here. And lastly, as a lanyard or as a little extra courtesy, they will still stick on the length of 640 for just for playing with us. So great. So yeah, Strago is spoken. It doesn't have a ton going on that you can actually interact with, but the algorithm is really, really interesting, and it's quite fast. So as will be this little talk. So thank you very much for listening. Just some things to keep in mind. Redis University, which I am working with. In August, we're going to have a new course, RU301, Running Redis at Scale. So we're going to be learning about sharding and distributed services within Redis. We're going to have an updated Redis developer certification going on. So I don't want to give you too much information, but it's pretty exciting, and a lot of people are going to be really excited for that. And then all of our Redis University videos are going to be released on Redis Labs. So we're just shifting all of our videos under the house of Redis Labs on YouTube channel. So yeah, like Guy said, meet us all on Discord. Come check out the university at Redis Labs. You'll see all of us. And yeah, check out and subscribe to our YouTube channel on Redis Labs. So thank you.
Thanks, Justin. That was great.
Thanks.
I want to come up with a reason to use this. I feel like I have a new golden hammer.
I know. It's very cool, but I'm like, I'm not a geneticist yet.
Yes. So excellent. Very, very, very cool stuff. So
thank you.
Thanks a lot. So up next, we have Otávio. Otávio, I'll go ahead and add you back to the mix here. And let's do this. Do that. There we go.
Whoops.
There we go. We got rid of Justin. We didn't want him around anymore.
Come on. Bring you back. I'd like to be.
We still love
I want
you,
to use the struggle again.
Yeah. I love that. It's one of the things that I actually really enjoy with Redis commands. I like pronouncing them when you shouldn't. Yeah. And so strago seems like a warrior's name.
Strago.
Zinkerby, the sorted set increment by, feels like the name of a wizard. He might live in the village of Hinkerby, So there's all these great ways you can pronounce Redis commands. It's just a lot of fun. But by far, my favorite one to say is smembers. So, so again, fantastic job, Justin.
Thank you.
I love these interesting corners of Redis that don't get used very often. So up next, we have Otávio. I'm gonna attempt to read his bio here. I'm going to awkwardly read his bio. So empowering developers.
You can say just a guy who loves to code and enjoy to be here with you to talk about software, beer, wine, and coconuts. Because I'm from Brazil, I love coconuts. I love drink water coconuts every single time. That's closed now.
I live in Ohio. We don't have any coconuts here, unfortunately. You can buy coconut at the store, but it's not the same. Most of the coconut I have has usually been covered in dark chocolate, which is still pretty good. So I think Otávio has just introduced himself. I think we should go with that. Otávio, let me bring your screen up here.
Okay.
The floor is yours.
First, thank you all to receive me here. So again, thank you, guys. Thank you, Justin, to Strago presentation. That was amazing. I need to find one way to use that as soon as possible. I don't know yet, but I will use that tomorrow. But today I'm here to talk about JNoSQL and what does that mean to us. So the tools that is around Java framework, and I will explore more the Redis NoSQL database. For sure, you know that NoSQL is not standard yet. We have several products that are working on that. However, it's not finished, and I'm not sure if we will have any kind of product to standardize this kind of solution in NoSQL database way. Therefore, we're looking to standard by language. For example, if you look to Graph database, we have two flavors. One is Apache Tinkerpop, that is JDBC to Graph database to simplify the The communication between the language, the Java language, and the NoSQL database itself, especially with graph. So with a single language, Gremlin, you can replace the NoSQL database if without impact the application itself. For example, if I decided to use Apache Ninkepop, I can use ArongDB, that's a graph NoSQL database, and then replace your Neo4j if I want to, if without impact the application itself. Therefore, we also don't need to learn a new API to do the exact same thing. Okay. Also, you probably know that right now the biggest challenge in NoSQL database it is because we have over 200 NoSQL database. Therefore, it's almost impossible to learn the whole APIs they're looking for. So we have a couple different types. So we have key value, document, column family, time series, graph, multimodal, and so on. But the whole point is when you talk about key value, uh, mostly we have a key and we want to return this information by that key, right? So yes, we want special commands power like strago for sure. But mostly in the mostly application, we are looking to something simple like give a key, return this value to user session, something like that. And that's why right now in the Java world, we are looking to a solution to that, to make that possible with JNoSQL. JNoSQL is built under Eclipse Foundation. So it's a open source product, real open source product. And right now it becomes a specification under Jakarta EE umbrella. The main goal here is again to simplify, to make easier to use NoSQL database in Java, and also avoid vendor lock-in. So if I'm using some um, key value NoSQL database and then I saw this presentation about struggle, so I decided to move on to Redis. You can do that easily because you can use this kind of standard in the Java language. Okay, my main goal here is to go more in the code, show more details about the API itself. As you can see here, I'm using my IDE. I already create my application using Maven, where I put my dependencies in my .xml file. My main goal here is to using this API, a single API, I can do basic operation and then um, see how it works. Okay, basically, JNoSQL has a different strategy where we have two layers. One layer is to mapping. If you are familiar with Java, you can think about the JPA, Java Persistent Past Tense, or Java Persistent API, where you have your class. You're gonna put some annotation to make easier to you handle this kind of interaction. And a communication API, where you can think about JDBC, also any kind of lower communication directly between the database itself and your application. Okay, so as you can see here, I'm using the XML. Yes, you can use Gradle if you want, but I'm old school, so I love XML file. I'm not big fan of YAML files. Sorry, to don't be a millennial. Um, and basically here I have a couple of dependencies. So I have the minimum dependencies to run this application. Uh, that is CDI, the dependency injection, and JSON binding to store JSON. By default, as you know, Redis store the information as text, and you can choose how you store that information in the class. By default, the specification choose to use JSON file. So if you have a huge class, it will become a JSON file where you can store that information to you. But if you want to, you can choose that to Avro, anything like that, binary code, binary source, and so on. So I have my minimal requirement here, CDI, JSON bind, micro profile configuration. Why do I have configuration here? Basically, it's to avoid to you to put any kind of critical information directly in your code, for example, user and password. And the product dependency itself. The mapper, where I have my mapper to document in the key value. Why do I have two different kind of dependencies to mapper? Basically because document has one single API and key value has one single API. The main goal here is to understand that key value has behaviors that matter to NoSQL database as document has behavior, and that makes sense to have one API to one NoSQL database type. Therefore, when we will support time series, we will have an API specifically to time series, because we understood that try to use this async API to all NoSQL database first is almost impossible, and second, we will lack this kind of information. And as far as you know, we also need to make a use extensible be extensible enough to use particular behavior in a NoSQL database. For example, I'm big fan of Redis and I want to use strago. My API should allow me to do that. Otherwise, it doesn't make sense to use Redis if you're not able to use this strong power, for example. And mapping and my communication, again, if you're familiar with Java, my JDBC, where I have my driver communication, one to MongoDB and other one to Redis. And my whole point here is, if I don't want to use MongoDB anymore, you can change this driver to another document NoSQL database that we have support. For example, AronDB, Couchbase, and so on. Okay, so those are my dependencies in my product. Beside my dependencies, I also have my configuration properties. This one here is on my properties file. Why do I have this kind of file here? Basically because with Eclipse microprofile configuration, I'm able to replace this information on production, overwriting these properties with system environment. If you are architect, if you're a senior developer, you probably know the 12-factor application. And yes, the Eclipse microprofile allow me to replace any kind of configuration, following the good practice to any kind of cloud application. So that's the main goal here. So that's why I have this configuration here. It's a basic configuration to run locally. So I have my provider. So this one here, once I will run Redis, I will put my Redis configuration. And my database to key value, that is Olympus, because I usually prefer to work with Greece mythology. Okay, so my first step here is, okay, I have my dependence, I have my configuration, and then let's create my first class. So I will create my god empty here. My god basically will have an ID. Just make that easy. So I will create a long ID with the name of the god. So name. And the last and the most important one for sure is the power, right? Because the power matters a lot when you talk about God. So powers. I will have my constructor with the three methods here, and I also will put my constructor empty. And also, I don't want to use any kind of front end or any kind of fancy technology. I will put the toString here just to show step by step about my code. So I put my toString here. I have my constructor, and basically that is it. So I have this entity here, and my main goal is to use this entity to do basic operation, especially with Redis in Java. Okay, so I have my app. I will have my public static void main. Okay, and I will create my first god. So Diana, because it's my favorite one, and I will have Diana, the god, the ID, and the name, and finally the power, where it has the power of moon, nature, and hunt. Yes, if you are father or mother, you probably do the analyze between Diana, hunt, and baby shark. Sorry for that. Remember that music. So right now I have this entity, and my main goal is try to start this information in my Redis database. To make that possible, I will use annotations. Okay, I need to define this class as an entity, so I will use the entity annotation. As you can see here, I have my package name, so jakarta.nosql.mapping.nt, and I want to define the ID as an ID, so I use the ID annotation, and I want to define the columns to store that information. Basically, I will copy paste that information. So based on that, I have my class with the annotation definition to define each information and where it should go. Okay, so that is it. I have my annotation here. Based on that, if you remember, um, especially when we talk about a huge architecture in the enterprise application, I want to have my container to inject my object or something like that. So to make that easy to us, I'm gonna use CDI container. So that's why I have my SE container to be my dependency inject container. And then I will use my SE container initializer, where I will create a new instance and then initialize. One good point, this API was built on Java 8, so if you want to, you can use the try with resource. What does that mean? Basically, I'm able to create a container, and then when my code is done, my container will fire an event to close everything that is open to me. So if I have multiple connections, like SQL database, something like that, after this code here, it will fire an event to close any kind of resource. So close anything here. Okay. So I have the basic annotation. I have my int. The next step is to basically store that information on my NoSQL database. To make that possible, I'm gonna use the templates. Templates is a basic class to do the interaction between the Java application and the NoSQL database itself. Once I want to work with key value, for sure I have my key value template. So let's make it possible. So key value template. Oops, now I have my template, and I need to use the container to inject these dependencies. So I will select this template. Oops, the class, and that is it. So I have my container. Basically, based on that template, I will do this kind of basic operation. So I will put the Diana, my goodness of hunt, nature, and moon, and then retrieve Diana based on the ID. So I will have my Diana based on that. As you can see here, basically I'm using the optional. Why do I have optional here? The main goal is to avoid the classic null pointer exception in Java. So instead of you handle the null point, you can use any kind of operation based on that container of instance. Okay, I will create, I will insert, I will retrieve, I will use a log here. So not fancy, sorry. It returns got ID1, then I will delete, and then I try to return again. So let's do the magic technique of copy paste. So, but instead of return this option here, I basically will copy paste this little guy here again. So again, I will inject my container, create my container. I will create a template. Template is the class between the Java entities and my database itself. And then do the basic operation with Diana. So I will run my application and hopefully it will work at first time. Oh, I forget something. It connection refused because I forget to start my Redis database. To make that easy, I create my Docker Compose and I will run this guy here. Sorry. Let's start my database instance again. So Docker Compose up, and then it will start the Redis and MongoDB. However, we will focus more on Redis database itself. So let's run again, and hopefully it will work nicely. And let's check. And as you can see, I insert my Diana. I put the information. I retrieve the Diana here. I create an offensive log. I delete. And finally, I uh, return again. That is empty because I don't have any kind of information in the database no anymore. And as you can see, I don't need to handle with an instance. So I can use this wrapper here to avoid the null pointer exception. For example, if I want to have my God here, so what can I do? I can do something like that. So God map God to string. Okay, let's put some get method here. So I want to return the name, and if it's present, I will show in the log. So let's run again. So I map the God to name, and then if present, it will print to me the God's name. Let's check here, and then as you can see, it returned to me Diana. So I don't need to do something like God is not equals new, then the get name. So you can avoid that. Basically, use um, the lambda operation because this API is built on Java 8 or higher, and optional to avoid again the null pointer exception. And usually, when you talk about this kind of API, especially in Java, the first question is why do not use the JPA? That's is basically because JPA was built to SQL database, and we are looking for a NoSQL API. So again, to make more easy to do this kind of connections, to run this kind of thing. Plus, I want to make sure that I have one API that's extensible enough to take at least the minimal partial behavior, and plus be extensible enough to run any kind of thing that I want to. For example, if you're familiar to NoSQL database, you probably heard about TTL, that is time to live. Basically, I define it how long the time the entity should be in the database itself. For example, here I want to put the information, and this database should be here for 1 second. So how can I do? I put my Diana again, and this time I will define a duration of no millisecond but seconds, and then I will put 1 second. I will return the information, and instead of delete, I will define my time unit of seconds, and then I will sleep for 2 seconds. Okay. Now I will put a throw in the signature. I will run again. So what do I want to do? I will insert Diana empty in my database, wait 2 seconds, and then do the search again. And as you can see, it will return empty because the information is not there anymore. Okay, so what did I do? So I do the basic operation. So create, return, update, and delete. I used the time TTL, the time to live object, and I can simplify anymore. So if you want to, you can do queries. It's basically string where there is a translation process to you. So you can use a nomic query to any kind of key value database, and the framework will translate that to you to the API itself. For example, I want to return my information, but this time instead of use the API, I want to use the text itself. For example, here I did the get, so let's remove this information here. I guess we don't need to use the duration anymore. And instead of the query by API, let's do the query by text. So what can I do? So I can do get one, the ID, and then Diana. Oh, got the class. So basically what I'm doing here, I will return the whole information as string, or if you want to, you can do a single result. And that makes sense to us, right? Because it's basically one information. So I'm doing get by one, and then I return the query result is results. So let's check what's going on here. Let's run my application. So basically, I do the get one, and the API will translate that to Redis or any kind of NoSQL database. Remember, to change my NoSQL database, I need to do 2 steps. One is to change my provider, and the second, I need to make sure that I have this dependence here, and I'm allowed to change that smoothly. At least the most frequent or the minimum API. For sure, if I want to use the struggle, I will have the vendor look into Redis, okay, or any kind of thing like that. Besides that, we also have the option to, if you want to, use the concept or the approach of prepare statement. So for example here, I can use prepare statement, so get ID. I will use the prepare statement, and then I can do the bind, so ID and then 1, okay? And I can do single result here, where my result is again. So instead of use query by text, I use I still using query by text, but with prepare statement. So let's run again. And as you can see, I have my the query result with my ID using prepare statement. But given I want to simplify a little bit more, so I don't want to use the key value template. I want to use, for example, an approach of repository. If you are familiar with DDD, if you use repository, you don't want to take the details on the client side. So what can I do here? You can create this approach of God repository. It's pretty similar if you are familiar with Spring. So I will create a God repository here. Repository where it will be an interface where it will extend the repository, where I will receive two parameters. The first one is my entity type, and the second one is my ID type. So I done. So right now I have my God repository, and with that I am able to first inject my God repository. So God repository, and then based on that I will select my God repository. One information here is once I have two dependencies, I have my document and my key value. I need to define each one repository I'd like to use. In this case, I need to use explicitly the key value. However, if I only have one API, for example, just key value, I don't need to do that. I can do the similar thing like I did with key value template, or I can use with add inject if you are familiar, for example, if you decide to create any kind of I don't know, good service. And if you want to, you can do the God repository, and then use the add annotation. And you can use the qualifier here. If I want to, okay? So with this repository, I can use the DDD approach. So I can come here, I can save, right? I can find by ID. So my God, and I can delete by ID, where I will do exactly something. So the fancy front end is my God here, and I will copy paste again. Just because, sorry, I'm not a front-end developer, but my whole point here is I can simplify if I want to with the God repository, where I don't need to handle any kind of detail of the implementation because the NoSQL database will handle to me by itself. So let's run this application here. So I run my query. It returned for sure, and the second one I delete and then try to return again, and for sure it's empty. And yes, if you want to, you can put the brother like Apollo. This time the god of sun here, and for sure, if you want to put more, you can create a list of Diana and Apollo. And right now you have more information database, and it does not change anything. But the whole goal here is to show that you can use a single API to at least the most popular and the more frequent behaviors in the NoSQL database itself. So let's run again. The main goal of the API is to decrease the complexity. So, okay, I want to use Redis, but if I only want to use the basic stuff, you can use that, the API. If you want to use the particular behavior, again, you have the option too, because we know that particular behavior in each NoSQL database matters a lot to us. Okay. If you want to, you can create, for example, find by query, where I have my optional god here, not the one here, but query, for example, query, and then ID, where if you want to, you can do the exactly query that I did. So add ID, and then I define an ID here. And my whole goal here is to, okay, I will get the ID. So, okay, find by ID. And let's run again. But this time, I run my query. So, by my query. Let's run again. And as you can see, I created the normal query with annotation, and it will return. One important thing and one important fact about this API, that we avoid to use any kind of emulation, simulation or emulation, something like that. Why? Basically because any kind of over engineer in the API, you impact the application itself, and that's not good, right? So we avoid to do that. For example, if you want to do this kind of thing like find by name, where by default it's not possible, right? Because we can talk about key value database, and mostly need to return the information from the key, and the name is not a key. It should return an exception to us, right? So let's try to reproduce that. Find by name. Oops. And string here should be a string name. So Diana. The return won't appear because it will return an error. Okay. Let's run again. And as you can see, it will return an exception because key value repository in general does not support query method. Because this kind of a complexity where you can do the query by any field that's not the ID. You can do that with MongoDB, for example. You can do that with Cassandra. However, need to create an index, and you might have issues with performance, but if you want to, you can do it. However, by default, it's not possible in the key value repository at all. So that's why it returns an exception to us. That's all I want to show to you today. So basically, I'm not sure how long time do I have, but my main goal here is to introduce to you the API of NoSQL database with uh, Jakarta NoSQL, JNoSQL. That's integration between Java and the NoSQL database, where I can decrease the complexity to use this kind of NoSQL. I can learn easily, and also I can avoid vendor lock-in. Okay, um, that's all from my side. I don't know how long time do I have, but I think it is enough. And if you have any questions, please let me know.
Yeah, if you have any questions, drop them in the comments below, in Twitch or in YouTube, and I can highlight them like this. See, this seems pretty slick. There's me. So I do have I actually have a question.
Okay.
So what's this look like inside of Redis? So when we create Diana and shove her into when we reduce this deity down to just a few key value pairs, are they stored as individual parameters in Redis? So is Diana's name in one key as a string and Diana's powers in a set, or is it use a hash, or what's the storage mechanism behind it?
Okay, that's a good question. That's a good one, especially to our Redis.
I got to see the Redis commands. Yeah.
Yes, exactly. So basically, what we have here is it will store the whole information on JSON. So let's show here. So let's see if I can show. 1 second. I have my Bitbucket manager here, and my main goal here is basically I have my key, where I have my valid key, and then we will set using JSON. So basically, it will start the whole information by key and anything else as JSON. Remember, that's the default behavior. However, it's pluggable enough to, if you want to use something else, if you want to, you can do it.
Cool. I can't help but think that this would play really nice with Redis JSON.
Okay, yeah. It's nice.
Yeah.
Please let me know. Send me an email or something like that.
Yeah, I think we should make Brian do that. So cool. Well, I don't see any other questions coming in from chat. So do you have anything else you'd like to add before we wrap it up?
No, just thank you for your time. Thank you, community. That's amazing to be here, and hopefully see you soon.
Yeah. Well, let me bring Justin on screen here. And I just want to say, of course, thanks as well. We do very much appreciate you coming and speaking here tonight. I know it's pretty late for you, or pretty early, depending on how you measure late. So I know it was an inconvenience, and I appreciate it. And of course, I want to thank Justin as well for introducing us to the brave warrior who knows what is best, strago. That is a fantastic and fun command. And of course, thanks everyone who has watched tonight and who hopefully watches this later on YouTube. I think we'll probably turn this into a YouTube video. We haven't figured that out yet, the details of running this Redis Monthly Live. This is month number 1, or month number 0, because we're programmers and we start counting at 0. Mm-hmm. So, but thanks for everyone for participating. Up next, we've got, let me get this over here, the after chat. So we're all going to drop in on Discord. So if you're not on the Redis Discord, you can join at discord.gg/Redis. On the Redis Discord, we've got category called Meetup, and there's some audio channels there, and we can drop in there and talk about the Meetup and talk about Redis and talk about really whatever we feel like talking about. No one's going to tell us we can't talk about something. So join us there afterwards. And everyone else, thanks for coming. And we'll see you. Oh, here we go. I almost missed this bit here. It's a good thing I had a slide, right? Don't miss us next month for the next Redis Monthly Live. You can join the Redis Monthly Live meetup at meetups.redislabs.com/redis-live. We'll be streaming this on YouTube, so join us. Subscribe to our YouTube channel. Follow us on Twitch. We stream it there as well. And so don't lose these very important links. And with that, thank you very much, sir. And I will see you all on Discord.
See ya.
See you. Bye.
Bye.